Hello and welcome to the Garden Railway. And if this is the first time that you've seen the programme, what have you been doing? Well, while you were doing it, we were installing a water feature, a rockery, a station area, we've laid track with ballast and we've put down power. But nevertheless, there's still one vital ingredient missing. Yeah, nothing's working. Come on. There are two types of people in this world. There are the controllers and the controlled. The controllers, well, they like to tell people what to do, don't they? People like my director over there. And there are the people who like to be controlled. Oh, nurse. But when it comes to railways, whatever which way you think, you really need to know about control of points, signals and trains. And Mr. Lionel Pike is back with us once again to show us what to do. Okay, right, let's start with signals and points. And, well, quite frankly, this is showing off, isn't it, a little bit here? What's this then, Lionel?
Well, this is a fully interlocking lever frame.
Right.
On the days of the railway in the 19th century, they had to adopt some foolproof system to make sure that they didn't set the points without setting the signals and warn the drivers.
Right.
And in those days, there were no electronics. So it was all done mechanically. You can't apply the points, for instance, without applying the signal.
All right, well, let's see that then.
I set the signal first, and you can see the signal interlocking bar moving. That now permits me to operate the point, and there's the point interlocking bar moving. When the train has gone through, I want to set back to the main line. I set the point back first, and then I set the signal back, and the signal locking bar moves. And that prevents you from setting a point without setting the signals first.
Now, would I be correct in saying then that that is what you would find in a real signal box underneath the floorboards?
Yes. If you go to lots of the preserved railways where they still have mechanical signal boxes, this is how it's done.
All right, so under the floorboard is all the locking system, above are all the levers, and then out of the bottom would come the what would it be?
Rodding, yes. There would be rodding from these rocker arms, as you can see on the signal here.
Yeah.
They will use rodding.
Okay.
And
so you pull the lever.
Yes.
And the signal goes up.
And you had wires for signals because the signals were counterweighted, so they always fell back into the off position.
Right. Now then, on this railway that you're working on at the moment, are you installing a system like this all the way around it?
No, we're going to limit the lever frame to operating all the point work close to the end to the station and the engine shed here.
Right.
The reason is that if you try and use a mechanical system over long distances, you'll get loss motion and you'll get temperature differences upsetting the rodding.
Look at that, I think I've got it, you know. Now, that was brought in using the power of electricity. And we can use electricity, I believe, for signals, points and trains.
We've got a very powerful mains transformer system there, and this is a very basic one. That will power just a train, but that one will power all the signals and the points.
See, this scares me, electricity, and electricity, more importantly, outside, in the garden, rain, where, you know, what's the problems here?
Well, basically, that unit, which is receiving mains through the grey cable, that should be in the train shed.
Right.
In a dry, secure place.
Right.
The outputs from that can then be fed to the track. You can take 18 volts alternating current off there for signals and lights and points, and 22 volts DC for the motors on the trains.
So that's a case of running wires, literally running wires from the control unit out alongside the track, maybe burying them beside or whatever.
Yes.
And this unit here, this cable would run to the running, well, we can see here, can't we? You've clipped it on as a demonstration onto the tracks. The power goes through into the train.
That's right. You'd have to put this inside a building because it shouldn't be used outside. And you would control the trains from the building with that one. If you want to control the trains locally, then you would have a switchboard like this in, say, a large model signal box outside where it's dry.
Can you run more than one train using this system?
Not with this system unless the railway is sectioned. So you can have one train operating one section of the railway on the same line, and then about 40 or 50 metres round another train running.
Now, this is a system that I like because we have got rid, haven't we, of all those fiddly wires and cables. I mean, this is radio control, isn't it?
Yes, indeed it is. The locomotive is battery powered, so there's no track power. The receiver and speed controller are in the van. Right. And then they provide power to the motor and the engine.
So that looks like a remote control that I'd use for a scale model car.
Or an aeroplane.
Right.
Similar machine, and this is standard throughout Europe.
Could we use it for steam as well?
Yes. The transmitters for steam are identical systems, except that we're using mechanical devices called servos to operate the steam valves.
Now, I've got a slightly different system here, haven't I?
Yes. You've got the American system.
Right.
And that's very smooth.
Thank you.
There's a distinct advantage between the two. And it's this, that is electronically controlling the speed. Whereas this is controlling it mechanically, then to electronics. The other great advantage is that with that one, nothing happens until you press a key. The batteries aren't operating until you press the key.
Right, so no power wastage.
No. With the European system, you have to have the power on all the time.
Well, let's have a look in here then. This is this right?
That's
so
correct.
Those are the batteries. I know there's quite a bit of electronic wizardry in there, isn't there?
Yes, it is, but the biggest space is taken up by the battery.
Right.
Now that's a standard model racing car battery, giving out 14 volts. It'll run this locomotive all day.
Right.
The receiver is just in there, behind the fuse and the coupling. And the American system uses a synthesizer for detecting the frequency. So that we can put this one onto a channel here, which is channel 3. If I switch the transmitter to another channel to operate, say, another locomotive, I go to channel 4, nothing now will happen to that locomotive.
But that one's going to crash. No,
no. And what we can do too is we can leave this train running. Now I want to go and deal with another train on channel 10. I can switch to channel 10 and I can control that train. Now that controller is now having no effect on this train whatsoever. That train's going on its own. To get back control, I must key back to channel 3.
Lovely, I like it. Right, you've got a green light on yours, I've got a green light on mine. I'm going to take this one up round to the station, I think. Hello and welcome back. Now then, in the first part of the programme, Lionel Pike showed us some very interesting forms of train control. But me being of my own mind, I've decided to go my own way and drag this garden railway into the 21st century. We are talking about DCC, aren't we, Jan?
Yes. Traditionally, you would control the voltage in the tracks, and all the locomotives on that track would go. And if you turned off the voltage, they would stop. This is radically different in that the voltage is on the track all the time. There's a superimposed digital signal, and each locomotive has a decoder which receives all the signals and sorts out which ones are for that locomotive and controls the locomotive accordingly.
Okay, so we can control each locomotive individually. That's the beauty of this system, isn't it?
Entirely.
All right, well, it's great in theory. Let's have a look at the practice of it. And the first thing that I would say, Jan, just looking at one of these controllers here, is this looks pretty much like a radio control to me.
It's different in that the radio control goes only from the controller to the central unit, which is in the shed.
Right.
But the train still receives their power and commands through the track.
Right.
There are several advantages. One is you don't have to install batteries in the locomotives, which is sometimes very difficult because there's no space inside. Also, the batteries here power only the commands, not the locomotive itself, so they last a lot longer. You don't get dead spots in your tunnels either where you can't control your locomotive.
So this is a reliable reliable system?
I'd say so.
Okay, so now I've got my controller. What goes from here now to the base station?
The base station gets all the commands and sorts and sends them all, plus the voltage, into the tracks to the decoders.
So how much wiring is involved at the base station? Loads?
No, almost nothing. You have two wires, one from the transformer where the power is generated to the central station, another from the central station to the tracks. And that's all the wires you need for the entire layout.
All right, it almost sounds too good to be true. Let's have a look at the final stage, and that's going to be the locomotive, isn't it? We need to install some form of chip, don't we?
And we just flip the thing open, and you see there are ports on the circuit board where the decoder fits in.
And that just fits onto it?
Yes, you just plug it straight in.
Right.
There you go. And then you set these 4 switches to the other position.
Okay, presumably there's a lot of soldering now to do or something like that? Something?
No, you're done. Basically all we do is we put the top back on.
It really is that simple?
Yes.
Okay, well, let's give you another scenario here, Jan. And as you know, my uncle has given me these lovely old locomotives, and I've taken this little diesel apart just to see what's going on inside. And as you can see, here's our motor. It's a very simple affair, really. The power is received via the wheels, taken by these brass strips directly to the motor. But I can see, Jan, that that's going to present a problem for us. I don't know whether it's slight or not, as regards fitting one of these chips. What's the solution here?
Well, here's the decoder, how it comes from the factory. You see the 4 wires. 2 of those go to the wheels, 2 of those go to the motor. All we have to do is interrupt the brass strips by just clipping out part of it, and then we solder these 2 wires to the power pickups from the wheels, and we solder these 2 wires to the motor. We find a spot somewhere in the locomotive to attach the decoder with some sticky tape, and we drill a hole for the wires to go through, and that's that.
Well, let's see some of this in action, shall we? Hey, there we go. That's my little Austrian tank locomotive off and running. And you've got the German one, haven't you?
Yes.
You're on 003 and I'm on 001. And it's worth pointing out, isn't it, Jan, that we've got a controller each, which is great, and we can control each train here. But I could control all the trains from just one if I wanted to.
You can have up to 8 of these, but 1 is fine.
This isn't as far as it goes, is it? Just controlling the trains. We can go a lot further than this, can't we?
And we have a more advanced control, which allows you not only to run locomotives in function 2, but also to control the points and the signals, to control several points at once. We call them switch routes. You don't have to set each point individually.
It will do it for you.
Yeah,
Gosh.
you can control 2 locomotives at once if you're banking, and you can program the decoders. You can program the top speed of the locomotives, how fast they accelerate, that type of stuff.
Yeah, I'm just going to try and speed mine up the hill there a little bit. Now, even that, Jan, isn't as far as it goes, is it?
No, you can hook up your trains to your personal computer. You can control every locomotive, every point, everything that's connected from your screen, or you can even do it completely automatically. You can and basically have a completely automated layout.
Yeah. Is that fun? I suppose it is to someone, isn't it? What's the future of garden railways? Do you think you can go any further than that?
I don't know. At the moment, that's pretty much all I can envision. Do you have any ideas?
No, this has got everything I could ever possibly think of. We nearly crashed there, you know. You ought to be watching this.
Well, you can always use the emergency stop.
Yeah.
I'm Paul Newman, and I call my railway the Clematis Railway. The railway is about 11 years old now. The first circle I laid in 1990, and then about 18 months later I laid another circle, and then about another couple of years later I laid the track that goes out the back round to the grotto, and then just a couple of years ago I laid the inner one to make a third track. I've named the stations after the locality. The main station is Norton, which is the village where we are, and then just to the eastern side is Provinder, which is an estate over to the east of the village. Rushet is to the south of the village, and Lewson Street is to the western end of the village. And when I extended the track out along the back of the garage, I thought I would call that station Sindale, because just a couple of miles from here to the east there's a very pleasant area called Sindale Valley, so that seemed appropriate. The station buildings I make myself. It's about the only part of it I do. I don't build wagons or locomotives or anything, but the station buildings, poor effort though they may be, they're creative to make. They're mostly made of plywood and so on, and they go through hell, of course, in the winter. I decided to make a village round the main station. The houses are made of solid cement. The other buildings, the signal box, I made that. I made the footbridge when I went to evening classes for metalwork. The Nissen huts are made out of tomato soup tins. I decided I'd got to do something to contain all the controls, and so I thought the only way to do it was to build a castle, which is of course a bit overscale for the rest of the village. It has lighting in it, so that in the winter the lighting in the fort together with the lighting in the stations and the lighting around the track all looks quite attractive, if I say it myself.
Another marvel in the garden railway world, and I do hope mine can look a bit like that, at least by the time we come to the end of the project. An interesting point, and one that I found jaw-dropping as I started going around filming these layouts, was the sound that some of these locomotives make. Sound not too dissimilar to this, in fact. Now, that obviously isn't the sound of a real locomotive. That is a processed sound. And, well, you either love it or you hate it. I suspect you'll love it, your neighbours will hate it. There is a volume control on these things, you know. The sound is generated from this marvel of modern day engineering. It's a computer processor there. Probably got more power than Apollo 11 had to go to the moon. They all seem to these days. As this card here receives power from the track, it generates that noise, and as it receives more power, the faster the sound gets. The less power it receives, the less the sound gets. So it matches the speed of the locomotives. That is processed via an amplifier and that speaker, which you can see, to create that sound. Now then, all very nice, but we've got a problem. This processor is housed in the tender of a locomotive. And the one thing that this railway I'm putting in does not have is tendered locomotives. It has little tank engines, okay? So what I need to do is remove the sound processor from this tender and put it into something else. I've already started the job, and I'm going to put it into this old wagon. I think this will look quite nice being towed behind this particular little tank engine with a couple of wagons. Now, the first thing I did was take a speaker from an old radio and screwed it into the bottom of the wagon. In order to hear it, I've drilled some holes into the bottom of the wagon there. That is purely and simply so that we can hear the sound, okay? What I'm hoping is that this wagon will in itself act as a bit of a bass bin and give a nice, richer, fuller sound to that processor. That's what I'm hoping for. That's what I'm going to try and do. It is a little bit fiddly getting this processor out of this wagon. There's a little bit of screwing to do. While I get on with that, why don't you watch this?
My name is Michael, and this is the Great Wealdon Railway. We started this 5 years ago, and it is, I should say, a team effort. We've had 3-4 of us working twice a week for 4 years now, and it really works. We've got a field of an acre and a half, and the main station and yards, shunting yards, everything are around that field, and it goes round a perimeter, and then it goes across a level crossing over the garden drive through to another field on the edge of a pond, large pond and lake. We have a shunting yard where we shunt wagons for a purpose. We send down some coal wagons or some box vans, and then we've got another yard which is the permanent way yard, where we will have ballast trains going to. we've got full working semaphore signals. The ones around the station are rail-built, southern rail-built signals, upper quadrant. And then Max is very much in the Great Western, so to keep him quiet, out of sight, there are Great Western lower quadrant signals. And there are lots over at Dewsden Wood here. But they are all interlocked with the points, and everything works protypically as it does in a proper railway. And as long as you obey the signals and keep your nose clean, you cannot have an accident. The rolling stock, we've got two coaches. One is a Mark I and the other one is a fiberglass coach, which is not of any particular kind. And then there are wagons, which I have built personally. I think I've got about 30 now. They're all done from research, mainly southeastern Chatham, London, Brighton, South Coast wagons, and they're all absolutely protypical, right down to the finest, last nut and bolt. Apart from going bankrupt one day, it gives me a tremendous amount of fun, and your mind is never quiet for 1 second.
Hey! Jan was as good as his word, and he got my engine going. Look at that, my uncle will be well chuffed, as they say, when he sees that. And with a little adeptness here, let's just have a look at this locomotive. And hark, what is that sound I hear? My word, it's the sound of a steam locomotive. Which proves our little sound unit is working very well, and you can see it just in this wagon behind the locomotive here. That's the loudspeaker pointing downwards. You can see all the gubbins tucked away inside there. It sounds quite good. The bright ones amongst you will notice this is a different locomotive to one that we had on the kitchen table, and that's because our old locomotive isn't chipped up yet, so Jan has very kindly lent me this one. That's it from the Garden Railway. There's still a lot more to do. See you on the next one. Bye.